Hello, today we are gonna talk about retinoscopy and how to do it quickly and simply. If we have the two main meridians of the cornea perpendicular to each other, and we have difference between the two main meridians, that means we have regular astigmatism. Irregular astigmatism is unlikely to appear in the exam. If we prescribe glasses for this case, while using the plus cylinder formula, so the sphere will be the power of axis of lower bar, so the sphere will be minus 2. To move from minus 2 to plus 3, we need plus 5. Although the axis of astigmatism is 180, but we write the perpendicular axis in the prescription of glasses. Why? Because the cylinder of the glasses works on the perpendicular axis. While doing retinoscopy, you should have repeated fixed steps to avoid wasting of time in the exam and to avoid forgetting any step. For example, if you write your answer as bar cross or as prescription of glasses, you should do that every time. If you make the sleeve of the retinoscope downwards to maintain the plane mirror position, you should do that every time. And now we will start training on the American Academy simulator. We have a vertical beam at the 90 degree and we are scanning the 180 axis. Now we have a with reflex, so we should add plus lens. We still have a with reflex. If you have a high spherical error, you can use a high lens as a step, like plus 1 or plus 2 or minus 1 or minus 2. But if you have a lower spherical error, so you should use like plus point plus 0.5 or minus 0.5. Now we still have a with reflex plus 2 and we still have a with reflex. We should add plus lenses. We should have with reflex plus 5. We have a with reflex and now we can determine the axis. The reflex should be parallel and perpendicular to the beam. Using the sleeve, we make the reflex parallel to the beam. Now we still have a with reflex plus 7. We still have with reflex plus 8.5. Still have a with reflex plus 8.75. Now we have neutralization. If we add plus 0.25, we will have an against reflex, and that is the surest sign that we had neutralization at plus 8.75. Now we will make the streak at the perpendicular axis, which is 20, but we will be scanning the 110 axis. Now we have a with reflex, so we need plus lenses. Using plus 2, we still have a with reflex. Using plus 4, we still have a with. Using plus 3.75, we still have a with reflex. With plus 4, we have neutralization. Adding plus 0.25, we have and against reflex, and that is the sure sign that we had neutralization in plus 4. So now we have plus 8.75 at axis 20 and plus 4 at axis 110. Using the plus cylinder formula, the sphere is plus 4, which is the power of the lower axis power, and the astigmatism is the difference between them. We need plus 4.75 to move between plus 4 and plus 8.75. And the axis of the astigmatism is at 20, but because we are prescribing glasses, we will write it at 110. Now we have the step of higher marks in the exam, but we should subtract the working distance from the sphere. The cylinder is not affected by subtracting the working distance, so our answer should be plus 2.5 plus 4.75 axis 110. So our answer is correct, and we did transposition. In the exam, you don't have to do transposition, but the application here requires transposition. Now we will have another example. We set the working distance at 1.5 diopter and 66 centimeters. We have the beam vertical. But now we will make a more simple method, and it will take a shorter time. In the last example, I told you that while the beam is vertical, we are scanning the horizontal axis or the horizontal meridian. And again, in the prescription of glasses, we write the vertical meridian. For example, if the beam is at 90 degree, we are scanning 180 degree. And again, in the prescription of glasses, we write 90 degree. So my method is to consider the axis from the first like the axis of the beam. So if the beam is at 90 degree, we write the power of the axis at 90 degree. To avoid the two changes and coming back to the original point, so the negative of negative is positive. Two changes means no change. So if the beam is at 90 degree, we will consider it 90 degree without any changes. So now we have a beam with against reflex. So we should add minus lens. Adding minus 2, we have against reflex, minus 3, minus 4, still have against reflex. Now we can determine the axis by rotating the sleeve. Now the reflex is almost parallel to the beam. We still have an against reflex. Using minus 5, still have an against reflex. Using minus 5.5, we have neutralization. Adding a more minus lens, we have a with reflex, and that is the surest sign that we had neutralization at minus 5.5. But now we will write the same axis of the beam. So the axis will be 130. Scanning the perpendicular axis, which will be 40. As I told you, we should not determine the second axis because we already know the first axis and we got it right. So we have regular astigmatism and the second axis should be perpendicular to the first one. We have an against reflex, adding minus lenses, minus 2, minus 3, we still have an against reflex, minus 3.75 still has an against reflex, minus 4 we have neutralization, adding more minus 0.25 we have our reflex, and that is the surest sign of neutralization. So we have minus 4 in the same axis of the beam, which is 40. We now have minus 5.5 at axis 130 and minus 4 at axis 40. Using the plus cylinder formula, the sphere will be the lower bar, which is minus 5.5. To move from minus 5.5 to minus 4, we need plus 1.5. And the axis is 40, we will not change it. We avoid two changes, so we are on the original axis of the beam. Now we will subtract 1.5 from the spherical bar. The answer is minus 7, not minus 4, okay? Now we will write our answer. We have a correct answer. Again, in the first example, we were scanning the axis perpendicular to the beam. So we turned the axis twice. The beam was 90, we were scanning 180, and we were back to 90 while prescribing glasses. So we avoided the two changes, and while we saw the beam at 90 degree, we wrote it at 90 degree. And we avoided changing the axis again at prescribing glasses. So two changes that led us to the original point are useless. So we write the original axis once and avoid any more changes. This method is applied while you answer in prescription method, but if you answer in bar cross method, you should use the classic method as you use the scanned axis technique, not the beam axis technique. So again, in the scanned axis technique, this is the beam and this is the scanned axis. So we determine the bar of this scanned axis. And again, in the prescription, we write this axis. So in the beam method technique, I start with the axis of the beam and do not change it. I avoided the two changes that led to the same result of the original axis of the beam. Thanks and wait for other videos, inshallah.